Hi everybody, this is Mr. Packard. We've been talking about the law of conservation of mass. We looked at glow sticks, we looked at two labs yesterday and a video of a lab, and now we're going to apply this to chemical equations, and we're going to be looking at what we call balancing equations. So we're going to be applying the counting of the atoms that we did on Monday using subscripts and coefficients, chemical equations, and the law of conservation of mass, putting it all together. The rule for this on the worksheet, and I have the notes all written for you, so all you got to do is follow along, is that the same number of atoms of each element have got to appear on both sides of the chemical equation. So the first thing that we're going to do when we take a look at these chemical equations is we're going to count atoms. Is there the same number on each side of that equation? If it is, and it's balanced, we don't have to do anything. We just write the word balanced next to it and move on. If it's not balanced, then I'm going to walk you through the steps to be able to allow us to be able to make it balanced. So here are the steps. The first thing you do is to make sure that you copy down the chemical equation correctly. Second, you're going to list out and count the number of atoms of each element on each side of the arrow. And I would list the number of atoms of each element and make sure that you do it in the same order. That way you can look straight across from the reactant side to the product side and make sure that if they match up or not. And I'll show you how to do that. If you have counted the atoms and it's unbalanced, the only thing you can do to balance those atoms is to add coefficients. You cannot change the subscript at all. So if it's CO2, it's got to stay CO2, but you can put a number in front, the big number. And you continue to add coefficients until you get the atoms of each element balanced on either side. So after you add the coefficient, you check your work, and you keep adding coefficients until it's balanced. So what to remember? Make sure that when you're balancing chemical equations, you cannot change the subscript. If it is H2, it's H2, but you can change or add coefficients. So if it's H2, you can't make it H4, but you could make it 2H2. So we're just going to jump in and start working some problems. I'm going to work about the first three. Here's what my expectations are. I want you to show your work, and you can do it on the back of the sheet of paper if you want to. There's backs on both of them. There's also notebook paper sitting on the table. And once you get it worked out and you have your final answer, I want you to write your final answer on that worksheet for me and circle it so that I've got it and makes it easy for me to check. For this assignment, there are 15 equations. You need to balance 11 of them. One of those 11 is already balanced for you. And so if you find that one, you can just write the word balanced or balanced as is. If you want to, you can do all 15, and I will give you an extra 3 out of 3 on an additional 20% assignment. If you just do the 11 out of 15, then you will get full credit, and that's fine. So here's the first problem. Sodium plus I2 yields NaI. So the first thing I'm going to do is I'm going to write, you're going to list the chemical symbols, sodium and iodine, sodium and iodine on either side. We're going to count the number of atoms of each element on either side. So sodium is 1, iodine is 2, and then sodium and iodine, so sodium, there's no subscript there, so it's an understood 1, and iodine, there's just a chemical symbol there, so it's understood to be 1. Sodiums are already balanced at 1, iodine has 2, and on the other side, it's got 1. So I want to get them to be equal. Can I do this? And what I'm doing is I'm putting a subscript in between the sodium and the iodine. The answer to that is no, I cannot do that. I can't do that because that is actually changing what that molecule is. I can't change that molecule, but I can add things in front of it. So I'm going to rewrite the equation. And since sodium is already balanced, I'm going to tackle and try to make iodine be balanced on both sides. So what I'm going to do is I'm going to put a coefficient in front of NaI. And if I want 2 iodine, I'm going to put a 2 here. Now remember when we put coefficients, I always like to put parentheses around them. And you're multiplying the coefficients by the subscript. So sodium is equal to 2, iodine is equal to 2. On this side, you have sodium is equal to 1 still, and you have iodine equal to 2. So now we have fixed the iodine problem. We have not fixed the sodium problem. So if we look over on the left-hand side, I need to get sodium to be 2. So the only way to do that is to put something in front of sodium, a coefficient. Now, if I put something in front of that, will it affect the I2? And the answer to that is no, because there's a plus there. So I'm going to put a 2 in front. And so 2 times the 1 subscript changes this to be 2. We have 2 iodine on either side. We have 2 sodium on either side. And I'm going to take that balanced equation. I'm going to write it on my worksheet. And I'm going to put a big circle around it on my work that I'm going to turn in. And that question is done. The second one, N2 plus O2 yields N2O. Always make sure that you write the chemical equation carefully. We're going to count atoms on either side. Nitrogen is 2 on either side. Oxygen is 2 on the left, and it's 1 on the right. Remember, I can't come up here and just put a little 2 because I can't change the subscript, but I can put something in front of there. Now, while it may mess up the nitrogen, if I've got to balance the oxygen, so I'm going to put a 2 in front of there. So nitrogen is 4, oxygen is 2, which is what I wanted. So my oxygens are balanced. Right now, my nitrogens are not. Again, I can put something in front, in front of the nitrogen and multiply it by that subscript. I can put a coefficient in front of there. And so I can put a 2 here. And again, that will not do anything with this oxygen. And so 2 times 2, that's going to give us 4 nitrogen. And so we've got 4 nitrogen on the left, 4 nitrogen on the right. Oxygen is balanced. So I'm going to circle my correct answer. And then on the worksheet, I'm going to write the correct balanced equation. And then I'm ready to move on to my next one. N2 plus H2 yields NH3. Nitrogen equals 2. Hydrogen equals 2. Nitrogen equals 1. Hydrogen equals 3. So I don't have anything that is balanced currently. So what I'm going to do is I'm going to try to find numbers that go into the numbers that they have. And I don't know the proper math term, but you've got 2 odd numbers on the right and 2 even numbers on the left. So we've got to make sure that we can get those odd numbers to be even. And so what I'm going to try to do is I'm going to try to get nitrogen. I'm going to choose one to try to balance. So I'm going to choose nitrogen. I could also choose hydrogen, but I'm going to try to do nitrogen. So N2 plus H2. And I'm going to add a coefficient in front. And so I'm going to multiply that by 2. And again, you don't have to put the parentheses around if you don't want to. I always just do that to make sure I multiply all the way through. Nitrogen is 2, hydrogen is 6. Okay, so right now I've got nitrogen is 2, and I have hydrogen is 2. So I solved my nitrogen problem, but I haven't solved the hydrogen problem. So I can put a coefficient in front of the hydrogen, and that will give me 6. So I'm going to put a 3 in front of here because 3 times 2 is going to give me 6 hydrogen. And because there's a plus there, it doesn't have anything to do with that nitrogen. And so I now have 6 hydrogen on either side. This is my balanced equation. I'm going to put a big circle around that because that's the final answer. And then I'm going to write that correct answer on the worksheet. Okay, for number 4, we are now this is actually what is called a combustion reaction, because this is a hydrocarbon plus oxygen yields carbon dioxide and water. We're going to be taking a look at those next week. So now we're going from 2, we're going to 3 elements that we're going to have to balance. Remember, you've got to be able to count these atoms. So we've got 2 oxygen here, we've got 1 oxygen here, so that's 3, and you've got 2 hydrogen. So we've got carbon is already balanced, the hydrogen is not, the oxygen is not. So I'm going to rewrite the equation. And so what I'm going to try to do, I'm going to choose either oxygen or hydrogen to try to fix and get balanced. And so I'm going to start with the hydrogen. And so I'm going to put a coefficient right in front of here to try to get 4 on the right and get 4 on the left. And so I'm going to put a 2 here. So I have 2 oxygen here, and then I have 2 times 2 is 4 hydrogen, and then 2 times 1, which is 2 oxygen. Plus 2 oxygen here, which gives us 4. So this is balanced, but my oxygen is not. So if I have something that's right in front of here that I could put, that would allow me to be able to get 4 oxygen on the left-hand side. If I put a 2 here, that would give you a total of 4. And you have 4 on either side. Now that is completely balanced. I'm going to put a big circle around that. And that is the balanced equation. You would write that on your worksheet. From now on, you can work at your own pace and do the best you can. I'd be happy to work any by starting at number 5 or work any of them that you want me to. You guys can do this. Stay positive. You're intelligent. You can do this.